Morning, sir. My name is YASWANTH, under A2 slot 18B and with registration number 18BEC0375 under Dhanbal, sir. So, digital assignment was about to select a general related to the topic given for the floating point analysis regarding following up through different algorithms like addition, multiplication, subtraction, or the division or the precision carried out in it. So, I have selected the general dual mode, double precision, two parallel single precision floating point multiplier architecture. So this methodology of architecture, and I'm gonna clearly explain about the architecture which the journal which I have selected. So yeah. So for the first, the first question was about to explain how selected paper related to the COS syllabus or curriculum. So the paper I have selected, so which gives the information about the floating point multiplier architecture in both the dual mode precision to parallel mode precision, and we have and even in the normal class and the syllabus of the COA, we are clearly discussing about the floating pointer and its possible modes in different algorithms. So I thought this paper is closely related to the COA syllabus we are covering now. So and this paper presents a configurable dual mode precision floating point multiplier architecture which can also process two parallel single precision multiplication. So with this sort of specification, so which is really close to the topic, this generally is really close to the COS syllabus we are going on right now. So that's why I selected this topic. And the standard format for single precision floating point it was given here in the form of a small block diagram, and the standard format of the double precision floating point number is given in the form of a small block diagram. So these segregations and these I have collected from the journal. I have taken it, and the diagrams I have drawn through the drawapp.io.net, which is an online website which allows us to draw flowcharts easily. So, and the second question was about to draw the existing architecture discussed in the paper using appropriate raster graphics editor software in encapsulated protoscript EPS file format. So as the architecture is named as the double precision DSP multiplier, the proposed architecture is based on the standard state of art flow of floating point multiplication. So I've drawn these flowcharts using the app.io website, which is really comfortable to draw these diagrams, but of course it took time. But this is the surface level of the whole system algorithm, and its architecture is clearly shown up here in the basic format. So these were the diagram of it is of the existing architecture. So here. And the third question was about to draw the tabulated results of the graphs using office shoot encapsulated PostScript EPS file format. So for that we for on which the system is dependent upon on which parameters was clearly given here. And for double precision and double precision DSP, for the two modes we have clearly mentioned the parameters we are considering in, just like latency, area, period, or power. Everything was exactly given up here, the particular values to be followed on. So the comparison is made up here between DP and DP DSP, the two modes, and the comparison between the proposed between the existing and the proposed DP DSP also made regarding the power and area of the multiplier, and the comparison between the architecture as we shown at particular areas. I mean at the particular of the multiplier architecture, the particular area we selected, according to that how it changes the other parameters and how it affects the other parameters in the ultimate output was clearly shown up here. So these are the parameters and the calculation and basic calculation of shown up here. So the power processing metrics were shown up here in the form of graphs. So as you asked it. So that is up to the third question. And the fourth question is about to draw the proposed architectures discussed in the paper using diagramming and vector graphics application software and encapsulation PostScript EPS file format. So I used the app.io form and draw the proposed architectures discussed in the paper or the general I have selected. So this is the basic architecture of it, the proposed double precision floating point multiplier unit, which is the basic architecture. So that is up to the fourth one. And the fifth question is about to draw the transistor level internal diagrams using electronic schematic capture and simulation tools in encapsulated PostScript EPS file format. So The transition level diagrams were about the every single component which is mainly a part of a architecture which is really necessary to operate the whole system altogether. So DP and SP, I mean double precision, single precision, exponent, multiplexing components were clearly shown here. And the Mantissa multiplier, for the first operand and multiplier for the second operand, everything were clear. And the dual mode dynamic right shifting, which is a processor altogether to perform the architecture, to perform the whole operation, was clearly shown exactly the same way. How the process carries on one by one. So this is the order. To be followed, and I have drawn this. And I have drawn this flowchart. I have drawn these flowcharts and diagrams using app.iorap as I mentioned below before. Okay, this is about the fifth question, and the sixth question was about to compare the proposed architecture with the existing architecture in your reference books. So I have collected data from the journal I have selected, and I have collected some of the data from how generalized the architecture based upon this type of mode, this type of floating points which has these two modes of the multiplier from the other web articles. So I have altogether gathered some of the data and clearly noticed some of the key features that really distinguish between the proposed architecture and the existing architecture, as we can say the reducing the area affects the system and the efficiency of it, and other key features are clearly discussed up here in the two modes. And number 7 was about to list the advantage of the proposed design over existing design. So how beneficial it is to upgrade our system from the existing design so that it can clearly make a change and work efficiently than before than it used to. So as the proposed architecture has its limitations up to the value. So and that main advantage is proposing it is a Mantissa. So it is a floating. So it has a floating point. So it gives more precision. And other multipliers and the proposed feature of regenerability at runtime and self-repairability also enhance the performance of the proposed architecture. So and other features are also an added advantage than compared to the existing design. So these are the advantages. I clearly mentioned the other advantages as well. So and number 8 is list the merits and demerits of the proposed and existing techniques and hardware. So the merits of the proposed architecture and how are they different from the existing architecture is somehow similar to the advantages we have discussed in the previous question. So I have some of the data and how accurate I am clearly showing up on the merits proposed in the architecture with some of the key elements or key components, or you can say the key materials used, or even the particular parameters for the materials defined that which makes it have a better advantage than the existing architecture. So I have clearly mentioned up here. And of course the demerits, it also has some of the demerits, and what are the merits in the existing architecture and which are not present in the which are not present in the proposed architecture. So but comparative and also the demerits of the existing, but comparatively the proposed architecture has a better advantages and better features. Of course they also have a demerits, but still overall compatibility to efficiency, the proposed architecture has a better chance in developing further and resulting in a better system architecture. So that is up to the 8th question. And 9th question is about to list the applications of the proposed design. So there were many applications at the floating point operations of the key importance in several modern applications like 3D graphics, accelerators, digital signal processing. And digital signal processing is a vast subject, so it has many operations directly or indirectly involved. So it has many sort of applications present in the real world. So I've listed some of it like Sesame floating point multiplication, which is commonly used in 2D and 3D applications, for the graphic design and some of the graphic designing. Both SP and dual SP mode it possesses a maximum one ULP unit at last place precision. So it reduces the loss which is sufficient for the large amount of applications. So these are the basic applications which are really dependent upon the floating point double precision and single precision modes. So and the 10th question was about to draw a flowchart or algorithm of the transistor level circuit proposed in the design in the encapsulated postscript. So it was so I've done the flowchart how the process goes on. So as I've clearly shown above how the process goes on, like from the very beginning. It goes up into the double precision or single precision exponent multiplexing, and then goes to the Mantissa multiplier. From Mantissa multiplier to it altogether for the first operand and for the second operand, and then it gets into the right shifting or left shifting depending upon the mode. So for the dual mode it's dynamic right shifting. So depending upon the mode it goes about right shifting or left shifting, and then it goes to the and then it finally shifted Mantissa and normalization, and then we get the final output. So these what clearly it's shown up here. After the shifted Mantissa shifted, it gets to normalization, and then exponent update or rounding depending upon how the output we want, and then final stage and ultimately output. So this is the flowchart of the algorithm which is in the transistor level we are following in the system. System and the journal I've collected. So this is the ULP computation unit loss precision computation. So this is very minor. So the basic diagram was given up here in the logic gates. So this is for the this is what the data I've collected, and I'll get to know some of the knowledge about the topic and the journal I've selected based upon the digital assignment 2 questions given. So this is it, sir. Thank you.